All right, so we're going to go ahead and get started. Good morning. Thank you all for joining today's Research Radar Materials in Motion, hosted by the Minnesota Department of Transportation and the Minnesota Local Road Research Board. My name is Molly Yang, and I'll be your host for today. We're really excited to have our presenters, Jeff Stempiar, Vic Lund, Larry Zanko, and Ethan Peterson with us today. So today's webinar is part of our Research Radar series sponsored by the MnDOT Office of Research and Innovation and the Local Road Research Board. And every month we like to highlight research projects focused on a common theme. So before we get started, I like to read the Tennyson warning. This session will be recorded for those who cannot attend. If you have enabled your camera during the session, the recording may include your image, which is private data under the Minnesota Government Data Practices Act. You're not required to allow MnDOT to use your image, and there are no consequences for declining to do so. To opt out of the recording, you may simply turn off your camera. So MnDOT's Office of Research and Innovation manages over 185 research projects in progress that ranges from local initiatives to pool fund projects with other states that comprises both basic and applied research. We're here to help transportation practitioners determine whether new research is needed or if existing studies may solve your needs. We recommend the best research methodology for your project, help you access local, national funding sources, and manage your project from start to finish. Our partner, the Local Road Research Board, is a city and county-run organization that sponsors research and educational initiatives that address local transportation needs. And you can stay up to date with our research by following us online and subscribing to our newsletter. We'll send you website and subscription links in a follow-up email following today's webinar. If you have a new project or a research idea or a problem that needs solving, we're accepting new ideas on Idea Scale through April 1st, 2026. We also just launched a new landing page for Idea Scale. You can scan the QR code to access this. And again, this will all be sent in a follow-up email after today's webinar. So for this year, we funded 28 new academic research projects. If you'd like to see the full list of new projects, you can scan the QR code on the screen. If you have subject matter expertise on any of these projects and you're interested in serving on the technical advisory panel, you can reach out to our office by emailing us at research.dot@state.mn.us. And with that being said, I'd now like to introduce our presenters. So up first, we have Jeff Stempiar. Jeff is a pavement engineer with Nichols Consulting Engineers. He has over 22 years of experience specializing in pavement evaluation and design, material selection, and developing best practice guidance. He is a registered professional engineer and has worked on numerous projects at the local, state, and national levels. For our second project, we have Vic Lund and Larry Zanko. Vic has more than 18 years of experience as the traffic engineer for St. Louis County, Minnesota. He received his Bachelor of Science degree from Michigan Technological University in civil engineering and his Master of Science degree from Iowa State University in civil engineering with an emphasis in transportation engineering. His experience includes rural and urban traffic safety, intersection design, intelligent transportation systems, and transportation research. He was awarded the 2022 David B. Brand Safety Award from the National Association of County Engineers. He is also the current chair of the Minnesota County Engineers Association Highway Safety Committee, has served frequently as a technical liaison for Minnesota Local Road Research Board projects, and is a member of the University of Minnesota Center for Transportation Studies, Transportation Safety and Mobility Research Council. Co-presenting with him, we have Larry Zanko. Larry is a retired senior research program manager from the University of Minnesota Duluth's Natural Resources Research Institute. He is a graduate of the University of Minnesota, where he received a bachelor's degree in geological engineering and microbiology and a master of geological engineering degree. For more than 35 years, he led and supported research on construction materials, mineral byproducts, environmental impacts, and innovative uses of mining co-products. Lair partnered with MnDOT, the Minnesota Local Road Research Board, public works agencies, universities, and industry to improve transportation materials and support sustainable infrastructure. He has served as a standing member of the Transportation Research Board Aggregates Committee and continues to stay involved in geological and transportation-related research through regional organizations. And finally, we have Ethan Peterson. Ethan is a graduate of the University of Minnesota Twin Cities and started with MnDOT in 2016 as the state pavement marking and crashworthy engineer. In that role, he develops and manages pavement marking policies, guidelines, and practices, along with researching and evaluating new pavement marking methods, processes, products, and materials. He also develops policies, guidelines, and practices related to the crashworthy requirements for traffic control devices and temporary barrier. Before MnDOT, he worked in the private sector for 5 years, working on various traffic and road design related projects. And with that, we will have a Q&A session at the very end. And I like to pass it over to Jeff to get us started.
Thank you, Molly. Is my screen showing up okay?
Yes, looking great.
Great. The first one we'll kick off is talking about a study we did a couple years ago on pavement design around utilities best practice. This is very useful for local agencies. Utilities can be a source of maintenance, and so this gives some guidance on what we learned through various means of collecting data. So some of the background is utility covers, they're typically adjusted during asphalt concrete paving projects, also concrete paving, but for local agencies, mainly asphalt concrete. They include catch basin inlets, manhole covers, and also gate valve covers. Typically, a small pavement area is removed and then replaced, and this area is prone to distress. You can see in the image, this is not uncommon to see this or worse. That asphalt concrete will around the cover will crack, it'll settle. Sometimes the manhole itself will heave, or the asphalt breaks up over time and you can get potholes. Distresses, they're more pronounced in cold climates, such as Minnesota, especially when there's wet freeze and freeze-thaw cycles. Some of the impacts are reduced ride quality or potentially safety issues if there's large potholes. They can also damage snowplows that can impact the structures if they've raised up or if the pavement is settled. And then there's also additional maintenance cost to the agencies. There are two main types of cuts and materials used to adjust these structures. On the left, probably the most common is the square/diamond cut, and it's typically patched back with asphalt concrete material. The second one, and you'll see these throughout the presentation, is the round cut. It's after the paving is done, this one, contractor comes back and they actually core out or jackhammer out around the structure, and then they fill it with concrete material. In our study, this is used by fewer agencies, but it's gaining popularity and it's performing well. How did we collect data? Well, we did a literature search, and without no surprise, it's not well documented in terms of performance. But the key driver was the electronic survey sent out to agencies in Minnesota and in surrounding states. We received 28 responses, which I felt was really good. Most of them were local agency, or 28 from local agencies, one engineering consultant and one supplier. 67% of the responses were from Minnesota, a couple from North Dakota and one from Wisconsin. 5 of the agencies we contacted for detailed discussions and gathered a lot more information. These graphs show an example of the information we collected. So on the left is the color, material, and cut shape. And if you look on the bar that's around 70% total, is most agencies use asphalt concrete for the patch and the square and diamond cut shape. But you can also see some use the round for concrete and asphalt. On the right, when is the utility cover adjustment made? 76% reported that it's prior to paving the final surface lift. Some do it after, but I want to note that this is a key finding in the study, and we'll talk about it later. So keep this in mind, that prior to paving the final surface lift is important when you use asphalt concrete. So some of the factors contributing to pavement damage is the design details themselves, the cut shape, color material, what's used to actually adjust the utility cover, poor construction practices. So that includes inadequate compaction, lack of testing the materials. The backfill itself could settle over time. There's also climatic factors, frost heave. Agencies report that the entire drainage structure can heave. And then you have the freeze-thaw damage at the surface that can deteriorate the pavement. And then there's also traffic loading, and this is important if the utility cover is in the wheel path. That continued repetitive loading can damage the pavement. I want to highlight a typical sequence of the square diamond cut. So this one was shared with us from the city of Woodbury. First image is you cut out the pavement in a square or diamond shape, depending on the orientation with traffic, and expose the structure itself. After thoroughly cleaning, image 2 is they're actually installing plastic adjusting rings to get that cover to the right elevation. Once it's at its elevation, the city actually uses a geofabric to wrap the structure to keep the intrusion of fines over time or to minimize it. They highlighted that it's very important to, when backfilling, to use adequate compaction and do it in layers. Don't just fill the hole and then try to compact the whole lift of aggregate material. Image 5 shows the final, or the prepared base ready for asphalt concrete, and then 6 shows the patch in place. You can see there's still a gap at the utility cover because they're going to pave the final lift over the top of this. I'm not showing it, but the sequence for a round collar is, as I mentioned earlier, they pave all the lifts. Sometimes if it's an overlay, they pave right over the structure cover, come back, core it out, or most commonly jackhammer out in a circle and then fill it back with concrete. So now highlighting some successful regional practices that we found in the study. In terms of color, material, and cut shape, a one-size-fits-all approach was not identified. Agencies have their preferred method, and based on some local tweaks to the process, they feel like they're getting decent performance. So the study doesn't come out and say, hey, you should do this method. The square diamond with asphalt concrete, there is reported success, mainly if you do the work before you pave the final lift. Round cut, fewer agencies are using. It's more on a trial basis, but it is reported success also. In terms of adjusting the cover, as I mentioned several times because of the importance, is it's important to adjust it prior to paving the final AC lift. If you pave the final asphalt concrete layer, come back and try to adjust and do the patch, typically the distress is accelerated, it shows up sooner and it's more severe, and you now have a joint at your surface around that patch. And again, with the round concrete, again, mentioned a few times, it's important, this one's done after paving the final AC lift. In terms of the utility cover adjustment materials, there's standard materials and there's also commercially available products. Some things that came out is if you're using the concrete adjusting rings, the grout can fail early. There are non-cementitious adjusting rings that are showing promise, such as plastic that I showed you in previous slides. And then there's also steel adjusting risers that can just clamp onto the structure, the existing frame, and then raise that up the right amount so that you can pave around it and put the new cover on without having to cut and patch the AC. Sealing is very important. As I mentioned, geofabric. One agency actually casts the entire structure into concrete to help mitigate fines intrusion over time. And then plastic adjusting rings were mentioned as a way to help have a better seal. There's also some commercially available products, floating castings. Example is shown in the right. If you could see, there's like a slot and some bolts so they can actually adjust the cover height. And this minimizes the need to patch as much, especially just in overlay situations. You can see on the top, an example from Bismarck is this is an adjusting frame and cover. And you can see there's kind of a darkish red underneath the collar, and that's the part that's been adjusted up to the elevation of the final AC lift. Some agencies reported that these floating castings can actually help with the frost heave effects of the entire structure because then it can be adjusted, but they are also they're more costly. And I have to mention the disclaimer. I grabbed this image from a commercially available product. The report doesn't endorse or recommend any specific products. These were just what were recommended to the researchers in this, or were shared with us during the study by agencies that use these products. In terms of underlying material support, well-draining granular backfill material is very important. Adequate compaction, this can't be stated enough, is to get that compact in layers. You're working in a small area, so you're not going to get a roller in there, so you have to do the best you can with equipment that's available. Some things that some folks may not think of, it's important to cut enough pavement so that you can actually use the proper compaction equipment. You can see in the photo that this cutout has enough area for that compactor to actually work on the asphalt concrete, and it's not so tight that you can't even get in there and use the equipment. Now, it would be nice to see a small roller used, but again, we realize there's limitations, and this is probably what's most commonly done is using some kind of hand compaction equipment. Again, compact in layers. In terms of testing and inspection, simple things to look at is make sure the structure is actually adjusted according to plans. Check that it's at the proper grade and slope so it matches that of the surrounding street. Attention to detail is important, okay? Check that it's sealed properly. Check that the contractor's cleaning the surface before they install the risers. Test density. That's on the backfill and the asphalt concrete. And then if you're going to do the pave over method and come back and do the circle cut, make sure you record the GPS coordinates or survey it so you don't cut out random areas and then have to patch areas of pavement that there is no structure. Some other takeaways was, the performance around utility covers is just not well documented. It's not something that gets into asset management plans. So, and reoccurring pavement inspections are not focused on utility covers. They kind of look at the street itself. Most agencies said that this is typically inspected during a design phase for a street or if there's a public complaint. So one common thing that kind of came up as an idea is to actually collect some information during pavement management inspections. You could ask your team doing the work to maybe collect a sample around the city so that you can document how your structures are performing. We found that maintenance is generally reactive, and respondents did feel that we should move to a proactive method to slow deterioration. So this could be active crack sealing and patching, not just in response to public complaint. And then technology transfer across agencies is difficult. Folks are tied up with their responsibilities and roles. So oftentimes, two adjacent cities aren't even discussing what they're doing to help improve one of their practices. And then we wrap up with a sequence to help folks to evaluate and modify their practice. And this is an iterative process. So the key is first step is you have to inspect. You need to know what you have out there and document the condition. You may find that your utility patches are performing well. And it's not always the case, but you may be satisfied with the performance. So then the next step would be to evaluate your practices. Are we doing everything we can to ensure long-term performance? That might be reviewing your specifications, reviewing inspection and testing procedures, and taking an overall look at your practice. The next step would be to conduct trials, and this would be done with improvements that are made, such as different cut shapes, different materials, different specifications, following back to the process of inspecting and going through it. Once an agency's happy, that's when you can actually implement it and make it standard practice. Some other key takeaways in this process are it's very important to have an internal champion or champions to drive the process. If there's not someone leading the effort, it oftentimes falls by the wayside and doesn't take shape. Collaborate with your neighboring agencies. There's a lot of information out there, and you may be able to collectively find strategies to enhance performance, and then find what works best and implement it. And as people start learning your new practice, that's over time, you'll get better performance. But with that, thank you for your attention, and turning it back to you, Molly.
Thank you so much, Jeff. We'll pass it over to Vic and Larry for our next presentation.
All right. Well, thank you, Molly. And I think, Larry, are you able to share?
Yeah, just a second. Okay, just a sec. Great.
Well, Larry's pulling that up. Thanks for that, Larry. So this research is really focused on safety of horizontal curves. And Larry and myself, along with Dr. Barham and Dr. Maristano, have done a lot of research on this works to date. But we're going to go to the next slide and just kind of set the stage for why the research is really important. And the Strategic Highway Safety Plan really clears the air for us here. Lane departure crashes, you can see, are a leading cause of serious crashes in Minnesota. In fact, if you look at just fatal crashes, they're the top contender. So likely, if you're going to read an article about a tragic crash, it's probably going to be a single vehicle running off the road, probably in a curve, unfortunately. And if you look at where those crashes are happening, it's primarily on the state and county systems. And yeah, it's a rural creature. It's looking at those horizontal curves, and it's just the state and county system. Next slide. So the Strategic Highway Safety Plan actually discusses high friction surface treatments as a strategy, and it's a newer safety strategy that we're trying in Minnesota and nationally, but certainly it is a strategy that we need to be considering. Next slide. All right, so if you picture when you're a kid and twisting a ball around your head with a rope on it, that tension, that rope provides the tension for the ball so the ball doesn't go flying out into space. That's what happens between your car tires and the pavement surface. Your tires are the rope to keep the car from going off the roadway. And we think about improving curb safety. There's three variables. There's the radius, there's the super elevation, which is the subscription E, and then there's the friction, the factor F max. If we're going to reconstruct a curve to improve the safety of that, you'd have to reconstruct the radius, which is the R value. You'd have to reconstruct the super elevation, which is the slope of the curve. But we really don't have a lot of funding for that type of effort to go around and reconstructing all these curves all over the state. And again, they're the primary purpose or the primary generator of all these serious lane departure crashes across the state, okay? So from just simply a cost management standpoint, we don't have the funding to reconstruct, but we do have one lever to pull, and that is the friction value. And so the ability to increase the friction value in that horizontal curve so that it reduces the likelihood of a vehicle running off the road, particularly if a driver is entering the curve at too high of a speed that is just, too great for the maximum curve speed, maximum speed for that curve, excuse me. But this is kind of a hidden safety strategy. A lot of drivers out there really don't know that it's there or in place, which actually gives us a little bit more flexibility on the highway agency side, because we can still post those speed advisory signs that are accordance to a standard pavement surface friction value. But the underlying roadway friction is slightly higher, which means you could technically drive that curve faster, but we're not telling the drivers about that. So it's kind of this additional layer of safety, or this buffering of safety, so that drivers stay in their lane and don't depart from the roadway if they're coming into the curve too fast. With that, I'm going to hand it over to Larry, and he's going to talk about the specifics. And one more thing I'm going to mention, and then Larry will start here. My vision as a county engineer for this high friction surface treatment stuff, I think it's definitely a safety strategy of the future. We have very few tools in the toolbox to improve safety, particularly for lane departure, and this is one of those strategies. Currently very expensive, but as you're going to see with the presentation, we might have an opportunity here to utilize a lower cost HFST, high friction surface treatment, that will allow us to deploy this to much larger volumes of curves. So thanks, Larry. Go ahead.
Okay, great. Thanks, Vic. Thanks, everybody. Good morning, I think. Yeah. Anyway, as Vic pointed out, this project, we're focusing on friction aggregate, and the most common HFST is calcined bauxite, which it's energy intensive. It requires calcination, which it means firing it in a kiln of about 3,000 degrees Fahrenheit. It's fairly expensive. There's logistical challenges. Most of it is imported, say, from China. It has a high specific gravity of about 3.9, but it's very hard. That's why it's been used in this application. Mohs hardness of about 9 on a scale from 1 to 10. The alternative that we looked at during this project is taconite material, taconite aggregate. It's not energy intensive to produce. It's essentially just drying and screening an existing byproduct, which are taconite tailings from the iron mining industry in Minnesota. Comes from the Mesabi Iron Range, shown by the arrow there, and specific gravity about a third less than calcined bauxite, and its Mohs hardness is about greater than or equal to 7. So not quite the same hardness as calcined bauxite. But again, we wanted to show these two aggregates basically in a side-by-side application and assess how they performed over time. Again, the materials are taconite and calcined bauxite. You can see the microscopic images on the right, the taconite on the right, generally 100% fractured faces. So it's just the nature of how the material is made just by the processing of taconite iron ore. The bauxite on the left, the spec for the size distribution is shown on the lower left, about 100% roughly passing number 6 screen, and very little passing on number 16. So those are the two aggregates side by side. Again, the thrust of the project was to compare the two, bauxite versus taconite, essentially. And again, referring to taconite in our case as an enhanced friction surface treatment, or an EFST. The scope of the study was to construct 5 field sections with friction surface treatments, bauxite, taconite, and then we also looked at gilsonite-based frictions, gilsonite-based application, which is more of a pavement preservation, but with taconite applied. Laboratory testing was done. We did seasonal, spring and fall, after snow plowing, before snow plowing, throughout the project, and also conducted a cradle to gate life cycle assessment of the two systems, the system itself, the systems themselves, and then the production of the material alone. Again, the project location is located again just northwest of Duluth, indicated by the star on County State Aid Highway 15, which is just north of Trunk Highway 53. Again, the Mesabi Iron Range shown there on the left for geographic reference. The test sections were located again on County State Aid Highway 15. We refer to that as Mungershaw Road. And 5 sections that we looked at, the control, which we call number 0 on the south, continuing north, the 2 gilsonites, and then the focus of this project was really on the 2 HFST type systems with taconite and bauxite, again, as the focus. I wanted to point out that in 2020, St. Louis County installed a calcined bauxite HFST on the horizontal curb just to the south of our test site. So that's that inset on the map on the right. Installation was pretty straightforward. That was done on July 29th of 2021. A 2-part epoxy resin was put down. The aggregate is broadcast pneumatically and spread over the surface of the resin, and that's essentially how it's done. There's another option where an automated system can be used as well, as opposed to the pneumatic. In this case, a pneumatic system was used. Following installation, this is what the material looked like. The taconite on the top in the middle, shown next to the existing chip sealed pavement, and then the bauxite below that. Again, the 2 aggregates on the right, just for reference. The gilsonite-based, or what we call GSB systems, used a chip spreader distribution truck that deployed the pavement preservation emulsion and the aggregate simultaneously. It's very quick installation. To do one of the test sections, it took about a minute. Then it requires some time for the emulsion to break and set. But it's a different type of an application. This is not a substitute for HFST. We just wanted to look at a potential option for using material, taconite material on as an aggregate. Friction tests included 4 types: dynamic friction tester on the upper left, British pendulum shown there on the upper right, locked wheel pavement friction tester by MnDOT, lower left, and then the SCRIM, which is the sideway force coefficient routine investigation machine. I'll only say that once. We'll just call it SCRIM. And those were the 4 methods that we used to evaluate the pavements. Friction testing began with, of course, with traffic control. St. Louis County provided that throughout the project. We would set up with the DFT and the BP simultaneously. We had a lot of assistance from students from UMD and also from the University of Minnesota in the Twin Cities. Now the results. This is, again, the dynamic friction tester results shown from October 22 through the end of the project, which is May 2025. Bauxite is shown in red, in the thick red line, followed by taconite. And then the control is the dashed blue line, which is the chip seal pavement. You can see very little change. I think that's one of the key takeaways here that we saw in the 2 HFST type systems with the taconite and bauxite. Good friction numbers maintained through that period of time. And again, very little deviation, none at all really, from the two methods or the 2 aggregate types. Again, this is a histogram showing the DFT at the equivalent speed of the locked wheel pavement friction tester, which is 40 miles an hour, starting from August installation of 2021 through the end of the project of May of last year. And you can see the 2 taconite and bauxite HFSTs really stand out in terms of their friction properties relative to the other pavement applications. And the locked wheel friction pavement tester, these were tests that were run by MnDOT at least once a year, sometimes twice. Again, showing the relationship very similar to what we saw with the DFT, with EFST, HFST, taconite, and bauxite, clearly higher than providing high friction numbers relative to the others. Again, looking at it in a line graph, the control, taconite, and bauxite, again, considerably higher, typically about 35, 40% to 50% higher than the existing control pavement. But the key again, notice a lack of divergence between the taconite and calcined bauxite friction treatments over time. British pendulum was another method that we used. It's a good laboratory instrument. It's cheap, inexpensive. It's easy to run, but the differences aren't as pronounced. You can see that there is a slight elevation of both EFST and HFST treatments relative to the other treatments. But again, it confirms what we saw with the other two tests. But I think the BP is a better use as a laboratory instrument in terms rather than so much as a something that's more indicative of what the DFT and the locked wheel were telling us. And finally, the SCRIM, well, I guess I'll say it again, Sideway Force Coefficient Routine Investigation Machine was made available to us by WDM, the company that runs it. And I have a short video you can see. Does. And you heard that squealing sound. That's the tire that's attached to this piece of equipment. It's at a slight angle, so that's how it measures friction, and it operates at 40 miles an hour, or any number of speeds, but it can do miles or kilometers of testing in real time very quickly, and it's all georeferenced. So it provides a lot of data, including pavement texture. So, well, I'll continue on. These are the results of that SCRIM. And you can see the bauxite treatment that was done in 2020 on that horizontal curve is shown on the very left. We call that -1. Then the control is 0 and 1 through 5 for the other sections that we installed. The controlled pavement is shown as a dashed line, as a reference line. So you can see the pretty clear difference between the HFST and the taconite and bauxite treatments. Notable is the how the two sections that we installed compared to the section that was installed in 2020. Very comparable, even slightly higher for both. And the neat thing about the SCRIM is that its resolution is so good that it picked up some pavement repairs that were done on the two HFST sections, which were asphalt patches. You can see the drop off in friction that coincided with those patches, which is kind of a neat thing. Anyway, and lastly, the new GSB section, which is on the right, that one has showed good numbers relative to the control. The earlier installations, the aggregate to emulsion ratio was a bit too low, so it was redone in 2022, and that was the result we ended up with. And finally, the comparison of all 4 tests that were done coincident with the SCRIM treatment, showing how all, from the SCRIM on the left in red to the DFT blue, the locked wheel pavement tester in green, and then finally the British pendulum in yellow, how basically they all show the relationship with friction number fairly well, more strongly with the DFT and the locked wheel and the SCRIM. And just to reiterate, the DFT and the locked wheel showed really good agreement in terms of their numbers, good correlation. Finally, looking at the aggregate in 2025, just to give you an idea what the appearance looked like. Cores were collected by St. Louis County, and you can see that it's really not much of a change or a difference between the two aggregate types in terms of their wear. They're still maintaining good profile and reflected by their friction numbers. And then we looked at, between the wheel paths and within the wheel path, again, the HFST sections performing quite well relative in terms of friction values relative to the others. With that last GSB section, the new GSB, we refer to it, looking pretty well as well. Again, that being a better representation of that style of pavement preservation treatment. And LCA was done, cradle to gate. to compare the two HFST systems, taconite relative to bauxite sort of in that orange color. The epoxy itself accounts for, obviously, is a huge impact, regardless of which aggregate is being used. It accounts for nearly 95% of the total impacts in each category. But you can see the difference between bauxite and taconite. Taconite typically was about 30 to 55% lower, had lower impacts than the bauxite in terms of a full system. Now, when you look at the aggregate production alone, the difference is quite dramatic. Of course, bauxite being fired to 3,000 degrees Fahrenheit, shipped, et cetera. The environmental impact of taconite production of this aggregate type is 2 to 3 orders of magnitude less than bauxite. So in conclusion, again, the taconite and calcined bauxite produce the highest friction numbers, about 40 to 50% higher than the chip seal control. Taconite numbers were maintained within about 6% of the calcined bauxite throughout the project. So really no divergence at all from their friction properties. The couple of the GSB systems did pretty well, especially the number 5 was about 15% higher than the control. The DFT and block wheel pavement tests show really good correlation. Taconite, again, we just talked about the LCA, lower impacts environmentally. And collectively, we think these project findings suggest that the taconite friction aggregate can provide comparable friction performance to calcined bauxite at a significantly smaller environmental impact footprint. So recommendations for future study, we've gotten feedback from people out at TRB, et cetera. These were done on tangents, one not done on a horizontal curve. So that's what our next, what we would hope to be a follow-up project would be to apply this on horizontal curves to get more confirmation data on that. Likewise, incorporate crash modification factors into future evaluations, and lastly, recognize the taconite aggregate as an enhanced friction surface treatment, EFST. Since HFST has basically been appropriated by that, will be blunt, that part of the industry, and also is treated that way by FHWA. So it's more of almost a branding thing. So with that, I'd like to acknowledge all of the good partnerships that we had throughout the project, all of the people involved and the students and the organizations. And lastly, any questions we'll reserve to the end. So that's it for now.
I think this is when I take over. Thanks a lot, Larry. I'm Ethan Peterson. I'm the pavement marking and crashworthy engineer over at MnDOT here, Central Office Traffic. And I want to definitely give a shout out to the research team who I think are on here. And if questions come up that are too hard, I might lean on them. So sorry to throw you under the bus there, but we've got Ramez Haj, Dr. Ramez Haj, Fahad Ali, and Ablash Vyas. And I'll hop right in. We're just looking at the amount of bituminous surface loss each year that we have, and I think we've always realized this has been happening, but we want to try to figure out how much we lose, and I can jump into why here and what it affects. So the first thing is that we know we're a snow state, right? We have 30,000 plus snow and ice lane miles in any winter season here. And as you can see here, this is the snowfall distribution throughout the state. So what we tried to do was find differing areas. So we were looking at the metro area, which is where a predominant amount of our population resides. T1, where we get the most snowfall in the state, so we'll have more snowplows up in that area. And D4, which is pretty heavy wind, ice is maintained on a lot of those roads throughout the winter season. So we wanted to take looks at all these areas and figure out how much we're losing in these types of areas. And as I alluded to, there are three main reasons why we want to look at this. Selfishly, from my aspect, I want to look at the markings. We do groove in pavement markings in this state on most, if not all, of our new surface markings. So do we need to be grinding in our markings deeper? Or where are we putting them at the right depth currently? Rumble strips, both of these items are a very high value safety item, low cost as well. So we want to make sure that these are being maintained throughout the surface's life, or as close as we can get to that. And also just figuring out how it affects the surface, right? We know that it won't be the same from what was installed, and we kind of want to track and see where it goes with all of our snowfall and snowplow activities. So the big thing here is that there is a minimum retroreflectivity requirement that is being put on us by the feds come September 2026. Minnesota is well positioned to meet that, and we've actually we started with that the standard that they're putting on us a few years back even. So the timeline for the project, I will say that we're in the end of it. At the end of this year, we should have this project wrapping up. The first step was a literature review and survey, seeing where people were and what they felt they lost throughout winter seasons. There was a field study that we found areas, worked with the districts, made sure to get traffic control for the group, and got out there and took initial measurements, and then doing it through a couple winters, and we will see how it ends up. And then we will end up in the analysis and recommendations phase coming up here. And I will definitely give you what we're seeing at this point as well. So retroreflectivity, why is it important, right? This is the primary factor of actually providing light back from your headlights and showing the pavement marking on the road, sending it back to your eye from the headlight to the bead. It refracts, hits the actual marking, as we see here, and then reflects off the marking, refracts back to your eye. And this is the standard 30-meter geometry that they look at typically. And one of the interesting things about retroreflectivity, it is directional. So you can easily tell which direction a pavement marking was striped, because retroreflectivities will be higher. And that's an interesting thing that happens here. And this kind of just highlights how it is and why it is, right? These angles of the glass beads that we put in kind of fall more optimally in the direction of striping. And then as you look at it in the opposite direction, not as optimal. But we do, for yellow lines, which are the center lines, we do read them in both directions with a laser, and we can figure out the retroreflectivity, and we make sure that both directions do meet our minimum retros at the point of installation. So what else can we look at as far as pavement markings go? We're taking a look at how they wear and where they wear. So as we look here, we can see before winter, after winter. This is close to a brand new marking, as we can see here. This is after winter, and we can see that it's been abused quite a bit and seen some UV degradation as well. You can see here pointing out debonding. Debonding is attributed mainly to construction quality. Dislodgement is largely due to traffic and plowing, and the dislodgement refers to those glass beads that are in the pavement marking. And then you can see shaving that is largely due to plowing. And as we've alluded to, we know that we lose pavement, and we're definitely losing pavement markings at that point as well. So this is just a highlight of showing what they can capture. You can see around 64 beads were dislodged here in the wheel path, and I guess also highlighting that the wheel path takes a heavier beating because tires frequently go over that as well. As much as we wouldn't like that, we know that that is a reality. So looking at retroreflectivities, how do they look here? So data was collected at all these 4 sites in District 1, and readings were taken in both directions of travel here. As you can see, for the most part, we're seeing that after winter, it drops. We saw some interesting facts here. So for most sites, retroreflectivity was lowered after one winter, but there were some readings that were taking that when they were wet, and we saw which was pre-winter, and then after winter we saw them when they were dry, and a layer of water can severely impact that angle that light travels from your headlight to your eye, because it's adding another barrier. It has to refract through, so that geometry gets messed up and it doesn't send the light back as well as we would like. And you can see that there's a dramatic drop. Dramatic drop may also be due to initial drop for new markings. New markings do typically get hit pretty hard after the first season. Degradation of retros really isn't linear. So it takes a pretty big hit initially and then tapers off degradation afterwards. So just looking through the other areas, the retros here, this is the Metro District. So data was collected at 3 field sites in Metro District, and there were also a site without beads, which isn't going to give you good retros, and that one was actually discarded, which is good. It's an outlier, right? And as you can see here, the wet markings are also reflected in this one. So dramatic abnormality in here is due to readings taken when markings were wet again. Luckily, we'll have another winter, and we'll be able to track that a little more, or an after winter reading here, and we'll get to track these a little better here. So rumble strips, you can see here, which is interesting. So off of the baseline, so what this is showing is your internal noise of your baseline inside of the vehicle, the strike, which is, sorry, this depicts your decibel level above the normal, the decibel increase over your normal decibel driving before the hit. So they're hitting the rumble strip and then showing how it is before winter, after winter, and then this is the change in all of these areas here. And we have 2 different types of rumble strips in Minnesota that are predominant. And as you can see here, this is what we call rectangular corrugated rumble strip, which is a plunge cut. And then we also have what's called a sinusoidal rumble strip, which is a wave pattern that is under the surface completely, that goes in the pavement and gives you tactile and audible feedback there. The interesting part here is that we've seen actually an increase in decibel levels over ambient in the vehicle for rectangular corrugated rumbles after a winter, but we've seen a decrease in sinusoidal rumbles after snowplow hits and wear. So as we've kind of noticed in general, the corrugated rumble strips do give you higher audible feedback and increase after a winter, which is neat. So other readings that were taken here, this is one that they looked at, was mean texture depth, where they fill a portion of the roadway with sand, and that sand is translated into a macro texture depth. This is just an example, and you can look at how many patches they've done here throughout the project, and they can get the real world one, and they also did a virtual one here. And jumping to the key takeaways, as we're approaching 11 here. The amplitude parameters, which was SA, SQ, and MT, which is the average texture amplitude. SA, SQ is the net smoothing, and the MTD is the microtexture depth. And these also, they all decayed more at the center of the lane than the wheel path after winter, which is probably attributed to the plow hits. And then they also looked at the shape parameters, which is SSK, which is skewness, and SKU, which is kurtosis, or which describes the distribution of the shape. So this changed randomly after winter. Valley textures either deepened, shifted to peaks, or moderated with no clear centerline wheel path, but it's still good data to collect. As far as retro goes, retro degrades, but the cause remains kind of unknown. Just elemental wear, snow plows, I'm sure. And then there's a directional difference that's observed for how it's installed. And then rectangular rumbles became noisier in snowier districts, and sinusoidal rumbles showed the inverse. So that wraps it up for me. And here's the QR code of the study if you want to track it. And you can sign up for alerts if you would like to see the final report once that gets published. And yeah, and I think that we'll push on to questions, and I appreciate the time here.
Awesome. Thank you so much, Ethan, for wrapping us up, and thank you to all of our presenters. So now we will be moving on to our question and answer portion of the webinar. And I'm already seeing a few questions in the chat, and I've written them down. So hopefully I am asking the right presenter the right question. But I will also be unmuting everyone's mic. So if you want to hop on and ask the question verbally, feel free to do so. Okay, but moving on to our first question. I believe this is for you, Jeff, from Robert. What did the other category of repairs include? Minnesota has done some pavement adjustment using thermoplastic rings that can be stacked and melted for lower height differences. We have those in our thermoplastic pavement messages material contract.
Yeah, thank you for the question. So I tried to look quickly in the report, as some of the other ones didn't get documented in the survey, but I believe what they're referring to in terms of the other is that using the adjusting ring to allow the cover to be adjusted up a couple inches for an overlay without doing a patch. And then another response I found was that some just encapsulate the whole thing in concrete regardless of the shape. So I think you're,
Thanks.
yeah.
Yeah, thank you. I was kind of curious just how, it was maybe more, I would say more traditional type repairs, right? That, asphalt, concrete is what you're looking at primarily. So, all right. I just kind of know it's probably a mix of things. So I guess these are, like I said, it's a thermoplastic material that some of the vendors started making, the pavement marking, the thermoplastic pavement marking vendors started making. So they found them. Districts have found them useful, so we added them to our materials contract that maintenance uses. So, and they also have what they call at least one of the two vendors. It's Ennis Flint and Gaveco have products on the contract, and I think at least Gaveco has what they call a chip fill, which is essentially a ground up thermoplastic that you can fill up, small deficiencies before you put even markings down. So it works for both the rings and the markings. So kind of a interesting kind of, I'll call it quick fix kind of product that may not take care of the underlying deficiencies, but still addresses the height differential.
There's another one. It was called the chimney seal. I think the takeaways were anything is better than the old school concrete rings and mortar. I know people still use them. It doesn't mean it doesn't work, but it's just more risk of that mortar deteriorating and allow your intrusion of fines and then settlement. Thank you.
Thanks, Robert. And I believe the next question is also for you, Jeff. From Chris, does anyone fill the hole with concrete, then do the final lift as asphalt?
Thank you, Chris. We did not get that response. I'm sure it could be done. I could see an issue if there's, heave, where now you're heaving that asphalt layer and you have to now fix that patch. Most of them that I saw were related to doing the concrete after the final lift, and then you have that durable surface to kind of, or we'll have potentially less distress than the asphalt patch. And then Molly, I can see the next one with the density from Chris also.
Yes.
Yes, this was a reported example or issue, is that it's very difficult to get density. And also some agencies reported that the nuclear gauge doesn't necessarily work well when you're close to the concrete body of the structure. So yes, you probably are not going to get density that you would out in mainline, but I think it's important that there's some level of compaction in a specification. It may not be, 95% or greater, but some target that you can try to get some uniformity and decent density around that structure to hopefully mitigate the issues down the road.
Yes. Thank you, Chris, for your questions. And just moving down the line here, I believe this is for Vic and Larry from Mo. The MnDOT district would like to try out the high friction surface as a pilot. How might we go about it?
Well, a couple things to think about. The first HFST was actually completed by MnDOT that I'm aware of. I'm pretty confident on that, by the Metro District. I think it was on some segment of I-94 or maybe an off ramp or something like that. Typically, the HFST applications are put at more acute geometry or turning radiuses, that kind of stuff. So like ramps, curves, bridge decks sometimes will also be treated. So I would check with the Metro District. They have done it. St. Louis County has implemented about 30 curves with HFST treatments. We have specifications available, mostly copied from MnDOT. Happy to share that. In terms of if you want to try out the taconite based, let myself and Larry know. We can get you the specifications for what we used for this research project, and you could just simply substitute those gradations into your specification for the HFST.
Thanks, Mo, for your question. And then moving on here, it's either Malik or Malik. Sorry if I pronounced your name wrong. And I believe this is for Ethan. Is there a standard retail detail or spec reference for round coring pavement around manhole structures and placing a concrete collar, specifically the recommended core diameter, depth of removal, and concrete mix?
I think this one's for Jeff. Yeah.
I think,
Go ahead.
yeah, now that you
First
got
half
it,
is for me,
I think this one might be for you, Jeff. Yep, the concrete. Yep.
So I was looking through in the report, if you look at the appendix, Cloquet, Minnesota does use a round cut concrete. And I don't know, let's see if I'm trying to look quickly if they have the detail. I would reach out to someone at Cloquet and see if they have a standard detail. There's also one, Arizona Maricopa Association of Governments has a good detail on a round cut. I know it's Arizona, but there's also cold climates with lots of freeze thaw in the northern part of the state, and that detail's used there as well. So that's one we highlighted in the study. It looks like, yeah, I'd reach out to Cloquet. I don't see in the report that they reported a standard detail.
All right. Thanks, Jeff. And and going back to Vic and Larry, I believe this one is about high friction surface treatment. Is high friction surface treatment being looked at as a safety countermeasure for intersections here in Minnesota?
Not aware directly of any intersection treatments. Like I said, typically you're placing this on curves, off ramps, sometimes bridge decks, but I would say it's mostly curves and ramps, those sorts of things. I would say on the intersection question, if you wanted to, I mean, consider it, absolutely. It's a strategy. I think it would probably be more of a design specific or unique condition specific decision. Like, let's say you have a very steep profile coming into the intersection. You have a documented history of vehicles running through the intersection because of slippery conditions or polished pavements or something like that. I think that's definitely something to consider. I also placed a link into the chat on the HFST on the Federal Highways Proven Safety Countermeasures website. So there's a lot of great information on that link that I just posted about HFSTs, including some estimated crash reductions for placing HFSTs on curves.
Thank you, Vic. And I actually had some questions of my own that I wanted to ask. First up for Ethan, I'm curious if your team are able or actually quantifying the financial impact of yearly surface loss, or if that's been part of your research so far, or you just focused on more of the technical aspects of evaluating surface loss.
More just the technical aspects. I'm sure it could be quantified monetarily, but and maybe that'll end up being something, but we're looking at mainly just the technical portion of that now.
All right. And then for Jeff, you had mentioned that the pavement performance around utility covers are not well documented. And I'm curious to know if there is potential to use tools such as GIS or digital mapping to locate utility covers and integrate them into pavement design workflows so that, we're not waiting for complaints to go out onto the field and fix these pavements.
Yeah, great question, Molly. And a lot of agencies is, there's a lot of push in the asset management realm to document what agencies have, specifically drainage networks, water networks, underground. So yes, their agencies may already have this information in terms of where the utilities covers are located. So they could potentially, as part of pavement management programs, they could sample they could collect specific information around a sampling of these structures, get it into GIS, and then see if their system is working. And then it may be working fine, but then it allows them to figure out, hey, all these old manholes that we used technique A on aren't working. So now you can see, it just helps an agency to see the data and then use it to make decisions.
No, it's great because I'm even wondering if there's some cross collaboration between Ethan, your project on, calculating surface loss each year and also performance around utility cover. It seems like there could be some cross referencing going on there. And I see there's another question in the chat here, one from Michael. How is a circle large enough to encompass a utility cover cut into the pavement? Is that a special piece of equipment?
Great question, Michael. Yes, there is a core bit that's big enough to core. They use them on airports too to cut in when they core the in-pavement lights. I want to say it's like 4 feet, but don't quote me on that. A lot of times you do see that. What I see pretty common is they actually go back and jackhammer out the area with a spaded bit, and then remove that asphalt concrete. Try their best to smooth out the edges of the circle, and then place the concrete.
Yeah. Thank you, Michael, for the question. Okay.
Thanks. Can I just add part to that question too?
Yes. Go ahead.
The cross collaboration thought, kind of building on that. I work in the Office of Asset Management, and we do have some hydraulic structure coordinates for manholes. I imagine at some point someone's looked into that, but seems like an existing data set that also could be of interest. I'm not sure what my question is there really, but just another data set that might be available for the asset management slide that the first presenter had.
Thanks, Michael. And then I have one final question for Vic and Larry. So Vic, you had mentioned that this is, Taconite's high friction surface treatment is the safety strategy of the future. And I'm curious, how close are we to implementing Taconite as the enhanced high friction surface treatment? So what does that timeline look like?
Yeah, good question. I think we need one more research project to really get to that point. Larry, myself, and the others mentioned on that title slide, we're working to get a second phase research project funded. I'm pretty optimistic that'll happen. That'll probably take another 2 to 3, 4 years at least to complete that. 5 years, 5 to 7 years probably before we get to a point that I feel confident and others feel confident that we can start utilizing that. I think it's, but yeah, 5 to 7 years. I mean, it could be sooner if you just wanted to start utilizing taconite. I mean, we already have preliminary results. The issue that we want to do a phase 2 research on is put it in higher stress environments, more traffic, put it on curves with more truck traffic, higher speeds, that kind of thing. So we want to really stress it more to get a better understanding of its performance, because that was one of the feedback items we got from TRB, that we didn't place it in a high stress environment. Therefore, the results might be still questionable.
Thanks, Vic. All right, and looks like we are out of time. So I want to thank all of our presenters for giving such valuable information to us today. Thank you to all of our attendees for attending and participating in conversations with us on, strategies of the future. That's why we're here. We will be sending a follow-up email, as I mentioned at the beginning, with all the information. If you have any questions, feel free to reach out to our presenters here. And that wraps up our webinar today. So thank you all so much.